All right. So how did the homework go?
Easy.
This one easy?
Not bad.
You're saying it's easy after all. So
I'm
easy.
just an idiot. I wasn't paying attention.
All right. So purpose of the homework is all the work we've done to turn our statement into a syntax tree. We now want to undo by turning it back into a statement. Right? Exhilarating. Exhilarating. All right. So we start off at so what we want to be able to do. Let me just take this out for a second. Oh. We'll go here into driver. So right now we are saying we're getting our var def statement, which should be a syntax tree, right? When we print it out right now, it's going to look like an object, weird memory address. But what we'd like to do is we'd like to print it out and have this guy look like look like our original expression. That is, look like this, but probably with all the spaces taken out. Basically, we want to reconstruct our original statement from the syntax tree, which kind of is proof that it works, right? All right, so what we'll do here is we're going to go into our var def statement, and we're going to work in order here. So what's a var def statement? A var def statement is a var expression followed by an equal sign followed by a math expression. Correct? So what are we going to return here? We're going to return this dot, the var expression, concatenated with, we'll put a space in there, concatenated with this dot, the math expression. Okay, we're going to call these guys toString methods. Okay, that's it for that one. So that's what a var def statement is. So var expression is toString, followed by an equal sign, followed by a math expression is toString. So now we got to go do, let's do our var expression. What's a var expression is toString? Public string toString. We have to override that. No, I haven't returned anything yet. This guy's going to return var name. Done. That's all a var expression is. It's a var name. Then we need a math expression, which is the right-hand side, correct? A math expression is a left operand, a right operand. Both of these guys are expressions, followed by a op expression. Oh, I'm sorry, a left operand followed by an op expression followed by a right operand. So we're going to say public toString. Who? Yep. And we'll return this dot left operand dot toString concatenated with a space concatenated with this dot operator dot toString concatenated with a space concatenated with this dot right operand dot toString. Finally, here's our op expression. This guy's going to have a public string toString, and this guy will return this dot the op. Concatenated with, well, here we'll just do that. Now it's the string version of that op, right? All right, that should be it. So we've taught each of our objects how to display themselves, what the textual version of themselves is. And now we just go back out to driver, and now this guy right here, VDS, is actually calling VDS dot toString, which is going to call our var_def statements toString, which is going to call his var expressions toString, then paste in an equal sign, then or concatenate an equal sign, then call the math expressions toString. The math expressions toString is going to call his left operand toString, followed by the operator's toString, followed by his right operand toString, where the left and right operand are actually expressions, so these guys could be a couple of different types of animals, right? By our original guy here, this is going to say apple, followed by an equal sign, and then we get to our left and right var expression. In the event that this guy is a left, the event that this guy is a math expression on the left, like this whole thing is, we need to handle parentheses. Okay, we're going to see what comes out of this right now. But right now, this math expression, this whole thing, his right expression, his left expression is a math expression in and of itself. His right expression is a var expression. So whenever a math expression's expression, one of his expressions, is a math expression, we need to surround it by parentheses. And then we also need to tack on the semicolon at the very end.
The semicolon is just with the var_def statement.
var_def statement, yep. So here at the very end of the var_def statement, we'll concatenate on a semicolon. But let's go ahead and run this right now, and we're going to see that we get the right stuff, just not with the parentheses. Okay? Apple is equal to A times B minus C. Everything looks legit enough, but we lost track of our parentheses here because we didn't recognize that this math expression's left operand is actually a math expression. And we house math expressions inside of parentheses. So that was our trick here. So we're going to go back into math expression. We need to be able to ask a question. Okay? So we're going to say, can I do it? This might be a fun way to use this one. So I'm going to say, this dot left operand instance of math expression question mark. If that's the case, you guys forget about that operator?
What?
Instance of?
Are you going to need like 4 statements?
Oh, it's going to be sick.
You're going to do it all in one line.
Oh, yeah. All right, so this dot left operand, instance of math expression, I'm going to put that in parentheses. If that's true, then we're going to boil down to, I'm going to put in parentheses, the parenthesis concatenated with this dot operand dot toString, concatenated with closing parenthesis. Okay. Otherwise, just boil down to this. All right. I'm actually going to steal that exact same thing here for the left, for the right operand. So right operand is an instance of math expression. Surround right operand's toString in parentheses.
I don't know if one line is the best idea.
I don't think so.
You need a wider screen.
It's gonna be cool. Just wait. Just wait. So right operand.
You kill something for fun. And then you get to read through that. Yeah. You need a mouse on the screen.
This dot right operand is an instance of
Your screen jumped a few times.
yeah. I'll space this better here in a second. Just relax. Everything's cool. Not convert from string to Boolean. Does it not like this part of it? It doesn't like stringing all those together.
I wonder why.
That was totally legit. All right. So if so, let's say string result is equal to the empty string. If this dot left operand is an instance of math expression, if that guy is true, then what are we going to do? We're going to say result is equal here, plus equals, open parenthesis, concatenated with this dot left operand dot toString, concatenated with right parenthesis. Else, result plus equals this dot left operand dot toString. Okay, then we're going to say result plus equals this dot operator dot toString. And then we're going to have our if structure for dealing with the right operand.
What about handling for both?
Huh?
If both left and right.
This will. This handles whether the left is that.
Because his doesn't return until the end.
Yeah, I don't return till the end.
I see.
All right. So at the end of this whole thing, I've built up my result string and then I'll return it. Like that. Make sense? This is far less cool. All right. So now I should be able to run this. And there's my parentheses. Make sense? All right, so that was the, you want this still? What do you want? This guy. All right, so that was the homework assignment.
Was it missing an apple at the bottom?
I don't think so.
Oh no, it's okay.
I rarely write code that's not perfect.
Except for that one time.
Except for that one time last class and a couple minutes ago. I'll just do what you guys do, and I'm going to blame Java for why my inline if statements. I had a student the other day complaining that all their assignments they didn't turn in earlier this semester was because Angel was eating their homework.
What?
Was it Ryan guy? I'm not judging. I'm just saying. I could hear him saying.
All right, so how does Angel eat your homework?
I just thought I can't say that
Wants
here.
to say that to a teacher.
I just thought of something. No. You ever catch yourself before you say something?
It's like 17 assignments. It's like, Angel's hungry. All right, so this makes sense how this guy works. So this is kind of the power. This is another one of those recursive-ish type of solutions where we're relying on that toString method to over and over again handle the recursive calls. So even just inside of our math expression, this is the most complex one, right? This guy recursively calls left operands toString, where left operand in this case we know is a math expression. Make sense? So that's actually calling this exact same function, just a very different instance of math expression. Yeah.
What did you this instance of? I
Oh.
forget ever talking about that.
We talked about it, did we?
I don't think we did. Instead. You didn't teach us that.
No.
Mine only works apparently for very specific math equations.
There's no way I didn't teach that to you when we
Yeah.
first dealt with objects.
Didn't.
You may have.
Are we gonna have to go?
It makes
Is,
a lot of sense, but I don't remember coming across it. You might have.
This is a Boolean operator.
Mhm.
This returns true if this guy is an instance of this class.
Okay.
All right, so let's see. So if we didn't have that, how would we do this then?
I know a bad way to do it. It worked for the specific one.
Let's see. If we didn't have instance of, and we know left operand and right operand. What's an expression? Expression is just that. I know I'm going to get either a var expression out of that. Well, I suppose you would have had to use the documentation and look at the class name. So you could have done something like, instead of saying if it's an instance of, you could have said if this dot left operand dot get class is equal to math expression dot class. That's equivalent. So this is just comparing these two values. I would be very, very surprised if at some point we didn't use instance of. I'll give you extra credit if you can prove to me that we never. How do you prove to me? that we never-
Every single video.
Burden of proof falls on the person that. Well, I have all of our homework or everything we've done in class.
It's not in my toolbox.
Everything we've ever done in class, and you don't have instance of.
Is it our toolbox? The toolbox you wrote up?
That's not in the toolbox.
Well, didn't we lose some slides at some point this semester?
Still wasn't in there.
I don't think so.
No, I really think we did.
We did. Yeah.
I'm not just making
It was
that
like
up.
right before the midterm. There were like 5 or 6 missing.
You tell them to try.
Can
How
we
much you care? One
can we search?
Yeah.
Instance of, not found there. Does it only search one slide? Oh, here, let me. Can I select all? Select all. Found. I had to have used that in code at some point. I mean, there's some problems that would be very difficult to do without instance of.
We've done most problems. So.
Yeah, but we haven't really done like dealing with checking objects. What object we're getting, you know?
When we did linked lists, did we ever store different types of things inside of a linked list?
Nope.
See, I must have deemed you guys too stupid to go to that.
Oh, so now it's our fault.
It's Fair's fault.
Where is Fair? Where's Pebbles? Is Pebbles in this class, right?
Yeah.
He was training, remember the picture?
Oh, yeah. Man, that was scary.
What happened?
There was a picture with him and a lot of guys wearing backpacks.
They all had masks on, too.
Let's see. Okay. So in any case, that's what instance of is. It's a way to determine if a class is the same as another class. If something is an instance of another class.
Nope, we don't have it at all. Any of our work that we've done.
I need to email the people from Heroku and get a Heroku sticker. I like that. I like that sticker, and I didn't get one at the hackathon. I don't have enough stickers.
Well,
Are they going to be at the Chicago one?
Yeah, but I'll have to get a Heroku from the Chicago one.
Yeah. It'll probably be the same thing.
What if I'm taking a heavy risk? Well, speaking of stickers,
Talk to 'em
so I got my new car yesterday. My wife doesn't want me to get Austin Fat logos on it.
What'd you get?
Same car as that before.
Just newer.
1 year newer. I wasn't getting a new car, just my vehicle was leased. And since I sold my company, I don't really have to lease a vehicle now. That's like the best way to write a car off through your companies. Well, for like miles when you go and visit clients and stuff. But the day after he put the trailer hitch on my Flex, Ford calls me and says there was somebody looking for a used Flex. So I actually came in and they cut me a deal, and I got one model year newer, brand new Flex, basically the same car I had before, except this one has a moonroof and the tow package in black leather instead of beige leather. Same identical car otherwise.
Does it have the hitch on it?
This one has the hitch on it, right? So I made him take the hitch off. Yeah.
What's the difference between a sunroof and a moonroof?
Yeah, I don't know. It's a good question. But this one, like almost the whole ceiling is glass.
Oh.
It's got a moonroof right above you here. Then it has like two smaller ones on the middle seats, and then a bigger one around over the third row of seats. Like the whole thing's glass. In a hailstorm, this thing's going to be just a death trap.
Don't drive it through a hailstorm.
I don't know. That's a good question. What is the difference between a sunroof and a moonroof?
Do you know if it opens all the way? Like, does the whole? Do you know
It does. It's power, so it slides all the way open, or it has just like the vent
Yeah,
opening.
'cause in my mom's car, the
Yeah.
moonroof doesn't open all the way. It just like pops in the back. But if it opens all the way, then
You got it for us?
Originally, a sunroof was a solid body-colored panel that could be popped up or removed, whereas moonroof was used to describe any panel in the vehicle's roof that was made of glass, but they're not used interchangeably.
Okay. So it means the same thing now.
Yeah.
All I know is it was like a $2,500 option. Who would pay $2,500 to have a glass roof?
I used.
Well, I mean, I didn't have to pay for it. I negotiated all that out. I'm Jewish. They wanted to sell me this, like, what's it called, like a Xylon coating thing to protect it from scratches or something. It was gonna be like $1,500, and I don't know, looked it up online while I was sitting there, and it says, oh, a lot of these vehicles already have it on there, and they went and checked this one. It already had it in the hood and stuff like that. I told them I'd give them $200 for it to do the rest of the car. Took it. It's $200 you didn't have before. Well, then I found an additional incentive, $250 if you lease a competitor vehicle. We have a Honda lease for my wife. So that's another 250 bucks. I really got the Xylon thing for free. Pretty good deal. It's like, hey, you guys need to get rid of the 2014. You want it off your lot. It's not my All right. Yeah, bring me to all your car negotiations. What was I doing? Okay. So now let's kind of do a last step here.
Can you scroll down just a little?
Nope. All right, so now that we have a syntax tree and we have proof that a syntax tree is correctly built, is properly built, what would be the next thing that would make sense?
Do something with the stuff.
What would we use syntax trees for? Well, first of all, when we look at something like this, if I tell you, what should the value of this be? What would you say? What, if I tell you to do that math, what would you say?
You can't,
You can't. Why not?
because they aren't numbers.
Yeah, they're variables, right?
There's math to do that. That is the you're saying.
Yeah, so
that expression is equal to that expression, basically.
okay, so we really need the ability to handle variables so that we can turn those guys into stuff, right? Okay, now similarly, what if we changed this and did it, instead of variables, we had 5 and 7 and 3. Could we do the math for this?
And then
Everything short of being able to store it back in a variable because we don't have a variable environment. So now our math expressions, the left and right operators are math expressions. But ultimately a math expression, the left operator could be an expression. We need to have now what's called a literal expression. This is the literal 5. This is the literal 7. This is the literal 3. So we should be able to process expressions based on them containing literals. Variables aren't going to work so well for us because we don't have an environment to go and look it up. I can't go and I can't look up and say, what is the value of A? And find that 5 is stored in A. We can build a variable environment. And by we, I mean you. But initially, we need to process this. Okay? So we're going to go ahead and we're going to have our sample guy be 5 times 7 minus 3. And we want to be able to actually output the value of our expression. So we should be able to execute a math expression. Okay? So we're going to have to create a new object. It's going to be pretty similar to var expression here, except it's not going to hold a var, it's going to hold a literal, a value. So I'm actually going to steal, well, we don't need to steal it. We'll just So new class. Call this guy a lit expression, named after myself, of course.
It's not big enough.
All right, so this guy extends expression, and he's going to have a private. We're going to say in our language, we're a language of numbers. So lit expressions are always numbers. Kind of makes sense if we only support math expressions, right? Okay, this is not a real fully functional language we're dealing with here. So private int the literal. We'll have our constructor for this, lit expression. And this guy is going to, let's just look at how we did var expressions, yep. This guy will take in literal, and we'll say this dot the literal is equal to the literal. Okay, and then we also need to have a toString for this guy, just like we had in our var expression. So public string to string return this dot the literal. All right. Now, as we're handling math expressions, we have to expand our language a little bit. Okay, so we,
Question.
yep.
The homework, I didn't use this dot at all. What is the benefit to using this dot?
This guy right here.
Just
When I say this dot,
Yeah.
this part of it.
Yeah.
Two benefits. One benefit is it's much more difficult to misspell your variable names. If you say this dot, it gives you the list of variable names. The other advantage is there actually is a performance advantage, which I care less about. I mostly do it for the spelling thing. It's easier to just grab my variable names, so I could actually then pick more expressive variable names up here, not having to worry about creating short ones that are easy to type. Kind of make sense? So that's the main reason, but the performance benefit is I'm not relying on, if I just say the literal, like this, when it goes in, so all variables resolve to their most local definition. If I just say the literal, it's going to check to see if there's a variable named the literal in this local scope. When it doesn't find one there, it's going to bounce up to the next local scope, which is this guy, and find it's defined here. So we're actually sending it on kind of an Easter egg hunt. Whereas if we specifically say this dot, the literal, it's going to skip that step and just say, oh, you mean the field that belongs to this object. Make sense?
Yeah.
So kind of two reasons, I guess. Yep.
When you say scope, like if the literal wasn't in the field of with expression, would it then bounce up to expression and look there?
No. Well, yeah, it would. It would, because expression, this guy extends expression, so he's going to get all the crap that came with expression, including all of its fields. In this particular case, expression doesn't have any fields. Okay, expression is fairly useless in this case, except for it becomes a nice placeholder for us to have multiple kind of versions of expressions that could be on the left and right of a math expression. Make sense? But it would. So from this perspective, just to kind of complete the search space, it would search locally here, then the next level up is here. The next level up from that is expression, and the next level up from that is whatever expression extends, which is what? Object. Then we're out of options. If you're rooting around an object for something and you don't find it, you wrote something wrong. Okay, that's not it's bad news bears. Okay. So there's our lit expression. Nothing special about it. Kind of what's nice about the model we've created here is we're actually building, the very early basic baby steps of a language, right? And really now it's just kind of, grunt work. It's not hard what we're working on right now because we have these little tiny pieces. This is kind of, I guess I like to bring this all together and approach a problem like this, which is, admittedly kind of a complex problem. We're going to be dealing with the real complexities of language stuff in 470 next semester, which I think many of you are taking, right? Okay, so that's a cool class, but we'll be getting a lot more into the language features. What I want us to get out of here is that we're approaching a fairly complex problem. I mean, easily, this is the problem this semester that we've solved that's had the most number of objects, correct? Lots of little dudes floating around that all become part of this solution. And we need to think back and remember what's the purpose of object-oriented programming. Okay? We are encapsulating all the details inside of these little tiny objects so that when we use them, we can talk about them in terms of the object itself rather than the details contained within the object. That's the definition of encapsulation. All right? Any one of these objects, this guy is a simple, tiny little object, right? There's nothing complex or fancy about this guy in and of itself. Coming up with that understanding that we needed to create all these dudes, that's a little bit more important, correct? All right, so in any case, we have our lit expression, and now we need to go ahead and teach our math expression how to potentially deal with lit expressions as the left and right expression instead of our expressions. Well, instead of only var expressions. Because right now we support left operand can be anything as an expression, which is a math expression or a var expression. Now we're going to throw a third one in there called a lit expression. Okay? Now let me ask you this. If I'm in math expression here, and we're building the toString, when do we do something special? When it's a math expression. Otherwise, what do? We just call that guy's left operand, correct? What about when I'm parsing? Let's see. Yeah, it will be. So var def statement. Actually, we need to be out here at, I'm lost. All right, parser. So parser does what? Well, it goes through it. It starts off by our parse thing builds a syntax tree by calling parse statement. Parse statement comes down here. It gets the left side of our statement, followed by the equal sign, which it burns past, followed by our math expression. So a math expression is really where things change a little bit, right? So now we're going to try to read in our math expression. If the length was 0, we know we're dealing with another math expression. If we're not dealing with a math expression, now, right here, we have one of two things we're dealing with. We're either dealing with a var expression or we're dealing with a lit expression. And in our case, lit expressions are numbers. Okay? Go all the way up to the top here. Remember we had our legal op characters and our legal variable characters? Well, I'm going to throw another guy in there. I'm going to say private static final string legal literal characters, and this guy is going to be equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, followed by a space. Okay, so those are our lit characters. So now in parse math expression, this guy, if we're inside this else, we're just assuming it's a variable name, but it might not be. We need to find out, is this a variable name or is this a lit expression? Make sense? Okay. How do we find that out? How do I determine if var name, the guy we read in, so this is where we try to read in the var name, but now it might not be a var name, right? Now it's a token. Actually, let's call it a symbol. Symbol's the more language correct thing.
That would, well, symbol would only take in A, B, C, D. I mean, letter. It wouldn't take in numbers.
Oh, right now, I'm just changing the name of the variable. I'm changing the name of the variable to be a little more appropriate than var name, because it might not be a var name. Now it's either a math expression, a var name, or a literal.
But, I mean, that wasn't that, oh, okay, I see what
Yeah, all I did right now is change a variable name. It's no longer called var name, now it's called symbol. Okay, so if symbol's length is 0, then we know it's a math expression. Telltale sign, right? Okay, so we do our math expression-y stuff. Otherwise, we're not sure if it's a math expression. We're not sure if it's a var expression or a lit expression. Yeah.
Don't we need to know if it's a, I mean, couldn't you check up there if it's a number or not? Because you're checking to see if it's a legal variable, which is, right? Or is it just getting the next to it?
Oh, for legal variable characters? I'm trying to read something in here.
Yeah.
I get what you're getting at. Legal variable characters is this guy.
Yeah.
So what we really need is we want this guy to be a legal, we need to have a legal symbol characters. So I'm going to steal this. We're going to say private static final string legal symbol characters, and this guy is going to be equal to parser.legal variable characters concatenated with parser.legal lit characters. And we'll have 2 spaces in there, but that's not the end of the world. So legal symbol characters is just our legal variable and our legal lit characters put together. That's all letters and all numbers. Make sense? So then that allows us down here, this is what he was getting at, is when we go to read in our symbol, we don't want to give it the legal variable characters only. We want to give it the legal symbol characters. Get me something that is made up of letters and numbers, right? Then from there we can ask, well, this guy is, are you a math expression? But we get in here, we need to find out, is it a var or a lit expression? That's what we need to find out right there. Okay? So we need to have functions for detecting whether something is a var expression and a function for determining whether something is a lit expression. We really only need one of them to tell the difference, but so let's, you want to just write a is var expression? So we're going to have a function here, private boolean is var expression, and this guy will take in a string symbol, and var expressions only have the characters in it that match the characters that are in legal var expression minus the space. Correct? Because now we've already parsed it. The whole reason we had the spaces up above is for our parser. So how do I determine if whatever symbol is in this function, how do I determine if that guy is indeed a legal var expression?
Symbol is equal to a space or...
Well, symbol is more than likely going to be like if this guy is going to return true, symbol might be something like elephant, or in our example, apple,
So
or A, or B.
So then you would just check if
index
it's
of. Index of.
Well, index of is only going to give us a single character. I need to go through the entire symbol.
then you would just check the legal variable characters, right?
You check.
Mhm.
To see if it has the symbol.
So I need to go through and I need to say, I need to create a loop that goes through symbol, right? I'm going to check it one character at a time. And if I bump into anything that disqualifies it from being a variable, then I'm going to return false. I don't care what it was. I don't care how many mistakes it made. If I find one thing that means that this guy is not a variable expression, I'm going to return false. So we start off with our standard loop for going through a string. Nothing special about this. For int I is equal to 0, I is less than symbol dot length I plus plus. So this is our stock spin through string loop. Okay, and each time through there, we want to find out if the current character we're looking at is a legal character for variables. Okay, so how do I ask if the current character I'm looking at, the character at position I in symbol, is a legal character in our for variables? So symbol.char at I gets us the character. So now this is the character we're working with. I want to know if this guy is legal for vars. Or more importantly, I want to know if it's illegal. Because what I ultimately want to do inside here is I want to return false. This is my minefield, right? If I survive, I'm going to return true down here. So this is another one. This is our minefield design pattern. Okay, check every character. If you step on a mine, return false. Otherwise, return true. Make sense? So each time through, we're going to ask, is the current symbol we're looking at, does it meet some criteria? The criteria we're trying to ask here is this character not a legal character in variables? If it's not a legal character in variables, we stepped on a minefield, therefore we return false. If I found a number which doesn't belong in variables, we're done. How do I ask that question?
Parser dot legal symbol characters dot index of,
Legal variable characters?
or no, never mind, it's var. We're doing var right now.
Yep. So legal var characters, right? So parser dot legal var characters
Well,
dot index of, and we're checking the character symbol dot char I. And how do we know this guy's illegal?
if it's equal to -1.
Okay. If it's equal to -1, that means we didn't find it in there. Okay? But we need to throw a little caveat in. We also don't like spaces. And this guy won't actually break spaces. Okay? Because he supports spaces for parsing. Correct? So we need to throw, or this guy is equal to a space. If either of those things are true, if it wasn't found inside of var, or legal var symbols, or legal var characters, whatever we called it, legal variable characters, if it wasn't found in there, or if it's a space, if either of those is true, we're going to say this dude is not a var expression. Okay? If we go through the entire thing and always find true, or I go through the whole thing and find things that are legal to variable expressions, then we'll ultimately return true.
What's the, oh wait,
This is just,
Yeah.
if all that stuff is fine, or the current character we're looking at is a space, that disqualifies it. It's either disqualified on wrong characters or disqualified because it's a space. Okay, so now we have a little test function, test method, to determine whether something is a var expression.
Will it still work if the name includes a space now?
It would not, which is okay. I mean, that's fair for languages, right? Okay, so now down here, this is where we're asking, is it a var or a lit expression? If this dot is var expression symbol, if that guy returns true, then do our var expression crap. Same stuff we did before. Okay, except now it's not var name, now it's symbol. And we could change this to var expression. Else, we'll say we read a lit expression, symbol, and we'll set the left operand to a new lit expression, passing it the symbol rather. Except this guy takes in a int, correct? And again, we're assuming that we're going to give it proper input, so we can say integer dot parseInt, passing it the string that is symbol, and that'll give us our number. Right, so that's what we do in here. So we've just adapted our else a little bit to now differentiate between var expressions and lit expressions. Then we do our normal operator dealy. Now, second time around, symbol. If symbol's length is this, do our normal crap. Otherwise, do the same crap we just did. Oh, hold on a second. Else, do the same crap we just did. So this else and the one above is the same.
But you have to change it to the right.
Yep. And I actually should say this dot right operand. This dot right operand. Oh, it's not this dot. They're local variables. That's why it doesn't say this dot on it. All right.
And then symbol.
Bracket.
Symbol like symbol has to be this dot equal to this dot. Get next token of parse dot legal symbol characters
Which line?
up top. Down one.
See, these have line numbers here?
Oh.
Which line number?
131.
Okay. Oh, you want to give it legal symbol.
Yeah.
Legal symbol characters, just like we did above. So everything we're doing down here is identical to what we did above. It's just for the right operand instead of the left. Okay. So now this guy will support parsing literals. What's the end? Well, then I must be missing one up here too.
You just didn't copy it.
Oh, really? Whatever. Okay. So now I can feed it something like this. And I can run it. And I get my, notice it's now parsing lit expressions. And here's my output. Make sense? So based on this, assuming our math expressions, for right now, assuming these guys are contains lit expressions, I should be able to actually do the math. Correct? All right. So what we want to do is inside math expression, we're going to create a method. Let's see. We'll make it public for right now. So we're going to say public int process, and this will process a math expression. You would call it doMath? Is that what you want to call it?
We used to.
All right, doMath.
Haven't we done this before?
Well, not for a syntax tree.
Right, but still.
All right, so you like doMath. Done. Done deal. All right, so we're going to do math, and this guy is going to process the math associated with this particular guy. Okay, so we need to get some numbers, correct? Ultimately, I need numbers. If left operand is a lit expression, which is all we're going to support right now, right? So actually what I'm going to do is I'm going to put in some placeholders for your homework for right now.
Wait,
Okay.
go back.
Yeah.
You and that H word.
So I'm going to say if this dot left operand is an instance of var expression, homework crap here. Because for what we're doing right now, we don't support those. We support math expressions and lit expressions. And those math expressions better contain lit expressions. Okay, we need real numbers for this, for our in-class example. Else if, we'll steal this guy. If it's an instance of lit expression. Now we're good. So I'm going to create up here, I'm going to say int the left num. And we'll start this guy off at -1 as just a starting point. Well, actually, I don't even think I need to do that. I'll just say the left num. And then right in here, we're going to say, oh, I am going to need to do it for right now since we don't have a way for your if. Since we're not going to have this part written yet. It won't know that we definitely have a value because we're not necessarily going to be giving it a value here. Once you give it a value in here, we'll be fine. In fact, actually, we can I'll just do the left num is equal to -1 in there for right now. So left num is always -1 for var expressions as of right now. Kind of bad var expressions, but whatever. Okay? Then, if we're a lit expression, then we're going to say the left num is equal to this dot left operand dot, we need to get the number. Well, lit expressions don't have a getter for its value yet, right? I need to extract the number from that left operand.
Just take the two string of it and do that parse it.
Yeah, I guess you could, but that's probably not the correct object-oriented way of doing it, because we know that the toString happens to just be the string version of the number. It would be correct. Probably the more correct thing for us to do would be just to add a getter to our lit expression to allow us to get the integer literal. Make sense? All right, so we'll go to source, generate setters and getters and setters, and we want just a getter for the literal. Okay, so now we have that guy. So now I can say the left num is equal to this dot left operand dot get the literal. And notice how it went ahead and typecasted it for me. That is something new in Eclipse. It's never done that for me before. It's very exciting. Okay, why did we have to typecast it? Because this dot left operand is a generic expression. We happen to know, if we're in here, it's an actual lit expression. We know what kind of animal it really is, but it's in costume. Okay, so that's why we had to say, take the mask off. You are actually a lit expression, and I know it. That way we can call the get literal from it. Okay? Else, if it's not a var expression and it's not a lit expression, it must be a math expression. So we'll set the left num equal to this dot left operand dot. Oh, here, I'll get it. It's making me do my own casting. Very upsetting. Math expression, this dot left operand dot doMath. So the left num will be equal to whatever the math returns for the left num. Right? Then we need to do the exact same crap for the right num, and then do the math dictated by operator. Okay, so I'm going to steal this stuff. Now we're dealing with the right operator, or right operand rather. Okay. So now I have my left num and I have my right num. I have all the pieces. Fine. Well, what do I do with those pieces? Well, I need to perform some math based on whatever the operand is, or the operator, rather. So I'm going to go into my op expression, and I'm going to teach this guy how to apply operator. He's going to take in our left and right number, if this dot the op is equal to a plus sign, return left num plus right num. Else, if it's a minus sign, return left num minus right num. Else, if it's a multiplication sign, else it must be divide by right num. And this is always going to do integer division, so it would be whole number division.
What about module?
Did you change the?
Did we support modulus?
Yes.
Is the op up top is charged for you?
It's a char. So if we supported modulus, then we need to be able to support modulus here. Otherwise, it's division. All right, so our op expressions know how to take in two numbers and apply the operator that it is to those. So then what we can do here in math expression, since this guy ultimately doMath returns an int, we'll just return this dot operator dot apply operator to the left num and the right num. Make sense? Now what we're going to do is inside of parser, here's our parse math expression, and ultimately this guy is going to produce our math expression up here, the ME. So we'll go ahead and test this, and we're going to say system.out.println the right side math is concatenated with the me.doMath. Okay, so we'll tell it to do the math. What's our current math? 5 times 7 is what? 35. Minus 3 is 32. Here's our 32.
What'd you do? What'd you return in math expression for doMath?
Only awesome stuff. Math expression, I think it returned the operands apply math. Or the operator, rather. Operator, apply operator, left and right. I taught our operators how to do here's broken.
Local variable right the right num may not have been initialized.
How like demoralizing it is it when I just write these like walls of code. It's like, there you go, it's 32. I remember back when we still only had chalkboards to teach. Who was, Jesse was in your group, right?
Yeah.
He was telling him about what I taught Jesse's compilers class 15 years ago. I wrote like a functional compiler on a chalkboard, and he just copied the text and he said it worked. That's fairly rare, but you know, not for me, but for normal. All right. So this makes sense?
But you can't pick up scissors off the floor.
That's true. That's why we take all kinds, right? That's true. Very true, actually. Okay. So now hopefully we see here, even though we have a whole bunch of complex parts, it all kind of came together very almost like a kind of like it was meant to come together this way. Does that sort of kind of make sense to you? I'm not necessarily saying you could have written this from scratch. That you need to throw some experience on there. But once you have the pieces and you see the solution, you can kind of see everything falling together. And that's kind of our punchline for kind of well-written code, but that's modular. That's the purpose of object-oriented programming. It's the purpose of data structures. It's the purpose of this course, is ultimately being able to take projects that have lots of objects in them and use those objects together to solve a problem. It's no different than if we take this outside of the programming world and you're, if you're into woodworking or something like that, you're building a shelf. Okay, a shelf has all sorts of individual pieces. You're going to have to get your wood, then you have to manipulate that, cut it into some different pieces and stuff like that. And you have to have your screws, you have to have your supports. There's a lot of pieces that go into even doing what would, for a handy person, consider to be a simple task, right? Building a shelf. This is no different. We just have to conceptualize those individual pieces a little differently, okay? So now what we need to do, and actually what we'll see here just real quick. What if I throw an A in there?
I'm gonna just show it.
Answer will be, of course, -9. Oh, -10. I did the math wrong. Oh my gosh. Program's right, I'm wrong. -10. Why? Because we said that all of our expressions just return a -1. Make sense?
Yeah.
Okay. Now, what if we want to be able to support creating variables? So, for example, because we separate on semicolons, what if we wanted to be able to do something like A is equal to 5, semicolon. Then apple is equal to A times 7. So A is 5, 5 times 7, we're back to what we had before, right? So we get a 32 out of this, but it has to resolve A. We need to have some place to put A. So what we're going to do for our homework assignment, are you nervous? So we need to be able to handle a variable environment.
Are we gonna review on Friday?
Yeah, we'll review on Friday.
Thursday.
Thursday, yeah, whatever.
Thursday,
Whatever.
Yeah.
So this is the last one assignment of the year.
No, it's not. I guess.
We'll make it a doozy. All right. So, what you need to be able to do. Here, I'll write the comment in here. We need to be able to handle a new kind of statement. Let me allow it to be a multi-line thing so I don't have to keep doing slashes.
How did that change?
Huh?
Didn't it used to just do it like you could just do an opening one and then a closing one and they wouldn't have the asterisks in between?
You can still do that.
A var_def statement can now handle having a literal on the right instead of just a math expression. When this occurs, that variable value, let's call it variable lit value pair, needs to be stored somewhere so we can look it up later when we do math. Make sense? So when we bump into that section, I said, placeholder for homework in doMath, when we bump into something that's a variable expression, before we can process this math, we have to go look that variable up in our variable environment or whatever, wherever we stored it somewhere. Okay? You might choose to create a variable, let's call it environment object that holds two arrays. One array is the collection of variable, well, actually, no, that's not an object-oriented thing. You might choose to create a variable environment object that holds an array of variable objects, where a variable object holds a variable, or holds a var expression. Well, actually, we don't need to have a var expression. Holds a variable name and a integer value. The variable environment should allow us to add variables to it and retrieve the value given a variable name. Then finish doMath to support variables. Note that your parser must now be able to parse multiple statements in a row. Things separated by semicolons. All right, easy enough. Final homework assignment, final hurrah. For all the marbles. All right, so I'll put this up on GitHub, put it up on Angel. Good luck, Godspeed. It shouldn't be that bad. Shouldn't be that bad. Sounds worse than it is, but I've given you a lot of details here in this paragraph. All right? You're going to want to read this paragraph closely and paint by number. All right, I'll see everybody on Thursday.